What's going on, you guys? Mr. Allen here with some application of exponential functions, and I can assure you, it is going to be exponentially fun. All right, we got Snoop and Dre are moving to a new town, right? They're going to move in together. They're going to be roommates, right? In 2020, it had a population of 35,000 people and has been growing continuously at a rate of 2.7%. What will the population be in 2032? And also, assuming that this model is valid throughout this whole time frame, what was it in 2015? All right, I think first thing we got to do here, man, is I got to write some kind of an equation here. Big things to think about continuously, all right? So this means if I'm going to have a population over the course of time, right, it's going to be my initial population, my 35,000. That's the number that I've got, right? So 35,000. And since it's growing continuously, that's going to be like your A PERT or your N naught E raised to the RT, that type of formula, right? I'll even write it right here. Some of them you'll see for population will be N of T equals N naught E to the RT. It's the same kind of thing as like compounded continuously for interest, just sometimes using some different variables, right? I'm using P for population just because I feel like it, and I'm the one that's writing the problem, you know what I'm saying? Aight, let us continue. We got E raised to the rate, which will be 0.027 times T, right? I got to change that to a decimal, so move it back twice, 0.027. So now I have this function, this population model, as a function of time for this continuous growth. If this was declining, right, the people were moving away, then it'd be negative 0.027 for this continuum model. Awesome, fantastic. Now, we want 2032. How many years after 2020 is that? That's going to be, let's see here, 12 years, right? So P of 12 equals, then we have 35,000 e to the 0.027 times 12. Oh my goodness. How am I going to do this? I can't do this in my head. Oh man, I got to bust out that TI-84, you know what I'm saying? All right, so let's see here. We've got 35,000. There we go. Then second e, that's second natural log, those keys on the left-hand side of your calculator. All right? And then I'm going to raise it to the 0.027 times 12. Hit enter, and I've got 48,392.65. So we'll say 48,390. We'll round up 3. Sometimes we'll also ask you for like to the nearest 1,000 people. So that'd be 48,000, right? We'd cut that off. It would round down to 48,000. All right, so people, PPL. All right, cool. Lovely. Fantastic. Now, let's go with, let's see here. We said in 2015, so that's 5 years earlier. So we got one of two things. We can either decrease it, making it negative 0.027 times 5, or you can make time negative 5 since we're going back 5 years. Either way will result in the same thing. Check this out. I'm going to go with, still making time, we're going to go P of negative 5 here equals 35,000 E to the 0.027 times negative 5. Now think about this for a sec. If I plugged in, if I did negative 5 times 0.027, or if I did negative 0.027 times positive 5, the result is going to be the same. So it really doesn't matter which one's negative. Just don't make them both negative, you know what I'm saying? All right. So we got 35,000. Actually, you know what? I don't feel like typing that all in again, right? I'm going to arrow up. I'm going to hit enter on that bad boy. And I'm just going to go, hey, man, negative 5 right there. What's up? What's popping? 30,580 people, 0.056. So 30,580 people. Excellent. Nice. Fantastic. All right. You could also ask you questions on like when will a population reach a certain amount, right? Let's see here. Let's say when is it going to crack 50,000? Let's just do a little what if, right? Okay, what's a little what if? When is it going to crack? Actually, let's go with 60,000. Let's go a little bit more. So here's what I'm going to do. You got a couple options. You could go ahead and graph this thing, but since we're already relatively close to that 60,000 that I just made up, I'm just going to do a little guess and check, right? We can also use logs if you know how to work with logs, but some of these are just wondering like, hey, between what 2 years? So I'm just going to go, I'm going to guess like 15 right now. Maybe we need to go a little bit more. This could be, I could regret this, right? Let's see here. Let's go with 20 years. Let's see what happens. Oh, lucky guess. All right. So I take it then that the year prior, year 19, right? So year 19 after 2020 is where we end up going between from that cracking 60,000 people, right? We got a population of 60,000. So what year would that be, right? This is a what if. This is not written up here. So we are at 19 and 20 years after 2020. So between 2039 and 2040 population reaches 60,000 people. 60K, right? I'm cool like that. I'm going to use K. 60K people. All right. There we go. That's awesome. Fantastic. Wonderful. Little guess and check action there. We could have graphed it. That's another option. Solved it with logs. A lot of different things. I went guess and check because I was just feeling that, man. All right. Have a wonderful day, guys. I hope that helped. And again, have a wonderful day. I hope you had a wonderful day. See you.